Sequence control structure. Sequence or straight flow is the simplest form statements executed one after another. No decisions, no repetition, just step-by-step execution. Sequence is your foundation. Every program starts here. Let us create example programs for sequence control structure. Let's have the example. Number 1, let's say, let us write a C program. To compute for the sum, difference, product, and quotient of two integers being inputted. Again, two integers or whole numbers to be inputted. Now, we're going to get the sum. Let us make use of the variable name sum. Now, for the difference, let's use diff. Then we have the prod and then the quotient or code for the quotient. Now let us design first or visualize the logical solutions of the problem before we proceed the program. So let's create a flowchart first. So again, we start with this symbol, oval symbol, to start your flowchart. Then followed by the input. So we use parallelogram for the input. So our input we use num1 and num2. So we'll be using here num1 and num2 variables respectively. Then let us now proceed to the formula. Let us get now the sum. So sum is equal to num1 plus num2. Then we have diff for the difference. Then let us use this prod for the product. Num1 times num2. Last, we have the quotient. We use the variable quote here to get the quotient. Now, num1 divided by num2. So we have the input, process, and then next is the output. So displaying the results. So what are the output for the sum, difference, prod, and then code? You can make also use single, no one parallelogram for sum, then difference, then the product, and then the quotient. So in this case, if you would like to put that all inside this one parallelogram, you just have to separate that using the comma. Then that's the end of our flowchart. Then we put here the end. Now that we're done in designing the logical solution of the problem, we can now proceed to the program. So our program in C starts with this directive. Include directive stdio.h. So telling the compiler that we'll be using the input and output statements. And then the opening statement or opening point or main entry in C program is this. You put here main, open and close parentheses, then you have begin. Now this part is for the declaration of the variables that we use. We have num1, num2, those are integers, so we put there int. The same thing with the sum. If we add two numbers, two whole numbers, the output is a whole number. The same thing with the difference. If we subtract two whole numbers, the output is still integer. With the product, still with integer. Now with the quotient, if you are going to input, there is a possibility. If you're going to input two numbers, two whole numbers, there is a possibility that your output is a decimal value or a decimal number. Like for example, you say 10 divided by 3. So that will give you 3 point something. So to do that, put here div, then the prod. Then again, as what I mentioned, we put here the code under the float. Now, we're done with the declaration section. Let us start with the input statements for num1 and num2. Now, to do that, let us have first an output statement so that the users will be guided in what to do. So like for example, you put here input the first number. So that's very clear on what to do. So you're going to input the first number. Then the scanf. Scanf is the input statement in C. This is input statement in C. Whereas, again, your printf is an output statement. Scanf, so we have this syntax, open parenthesis, followed by this double quotation. You have to enclose it in double quotation, the format specifier for your num1. So, our num1 is an integer, so therefore we put there %d, followed by a comma, and then an ampersand, then the variable num1. The ampersand is for the address. That is allocating memory space for your num1. And then, the same thing. We put here input, the second number. So that is easy to understand. Scanf. So this time for the num2. There you are. We're done with the input. Now let us go to the processing. So let's put all the formulas here. Sum num1 plus num2. Then you have the div, num1 minus num2. Then we have the prod. So you have there num1 times num2. Then the quotient, code num1 divided by num2. So we're done with the processing. So this time, we're done with the input, process, and this time we will proceed to the output. Now to do that, another output statement here. Now we're going now to output the sum, all of those. Printf, let's say the sum is For example, I have a column here, then I just put here the format specifier for the sum, which is %D. So that is simply saying that the sum will be located here. The value, whatever is the value of the sum, will be located or stored there. So another output, the difference is %D. Again, that's a format specifier for the difference. Then again, you can actually put here \n for the new line so that the next output will be displayed below in the next line. So we put here \n for new line, then double quote, then comma, and then we put there diff. Printf, the product is colon %D followed by the \n and then double quotation, comma, and then we put here the prod. Then lastly, printf, the quotient is, so what is a format specifier for our flow, for our code? So that is float. So we put here %F. So we don't need for us to put the \n because this is the last line. So double quote, comma, and then what is the variable that we use? Code. That's the output statement. And then followed by the return 0, closing of the program, and then end. Let's have another example for the sequence control structure. Let's say you're asked to write a C program to compute for the area of a circle. And using the following formula for the area A is equal to pi times R times R. That will be the formula that we are going to use. Now let us design first the logical solution for this problem by designing a flowchart. So again, we start with this oval for the start. Next. So next to this is we are going to set or declare value for your PI. Now that is having a constant value of 3.1416 and so on, etc. Now, let us just use 3.1416. And then, this time, we input. So definitely, our input here will be the radius. So we put here the R. Then processing. Area is equal to pi times R times R. Then we have to output the area by using again the parallelogram. So area. And that simply ends the flowchart. So we put then the end. Now let us create a program out of this flowchart. So again, we start with this directive. A preprocessor directive include stdio.h. And then the main entry for the C program. Then begin. Now let us start with this. Pi 3.1416 So let us now declare that as pi is equal to 3.1416. So we're setting the value of pi to 3.1416. So that is under the data type float. And then also we can add here the area as well, because that will still give you a value or an output of a decimal number. So we can just put here the A. Then for the input, radius, let's have integer for the radius. And then let us now proceed with the input statement, not this one for the radius. So printf. So again, let us create an output statement so that the users will be guided on what to do. So let's say, for example, you're going to put here input a value for the radius, or input the radius. Then another scanf here. Syntax for the radius specifier. Since radius is integer, we put here %d. And then %r, semicolon. So you end the statement with a semicolon. Then done with the input. Proceed with the processing. So processing A for the area is equal to pi times r times r. And then output the value of area. Output A. So we do that by saying printf, or by writing printf. So the area of a circle is, then we put here the specifier for your area, which is f. Or by the way, we can actually have how many decimal places that you would like to see to be displayed on the screen. So if for example, if you would like to have 2 decimal places, you can just put here 0.2f for the float. So double quotation, comma, what is the variable? We have here a. Then another semicolon. So that's it, output. Then to end, we put return 0. And then that's the end of the program. So you can actually also declare this as constant. So we have constant declaration in C. So we can make use of cons. So we can just simply say cons. So for the constant declaration, we have the reserved word cons, and then space data type, which is float, then followed by the variable pi, then the value 3.1416. So that's how you declare constant declaration in C. If you found this helpful, please do not forget to like, share, and follow for more tutorials. This is Applied Intelligence, where intelligence is applied, not just learned.